Hello my dear friends, how are you all? I hope you all are good and fine. So my dear friends, you are very welcome in our lecture number 4 of some application of trigonometry. Okay my dear friends, so without wasting the time, let's start. Yes, so now my dear friends, today we are going to discuss angle of depression. Angle of depression. Okay, so now in previous lecture we learned about the angle of elevations, and in this lecture we are going to learn about the angle of depression. Okay, so the angle of depression is formed when the observer is higher than the object he or she is looking at. Okay, means it is saying that the angle of depression is formed when the observer is higher than the object he or she is looking at. Means it is saying that in angle of elevation the object is higher as the observer. Now in this case the observer is higher than the object. Okay, I hope you get this point. So when an observer look at an object that is situated at a distance lower than the observer, an angle is formed below the horizontal line draw with the level of the eye of the observer and the line joining object with the observer's eyes. Okay, so whereas the angle of elevation is the angle formed if a person stands on the ground. Okay, if a person stands on the ground and looks on the object kept above the ground at a height. Okay my dear friend, I hope you get this point. So that the angle is formed is called angle of depression, angle of elevation. Okay my dear friend, so there is a difference between angle of depression and angle of elevation. Okay, so when an observer looks at an object that is located at a distance lower than the observer. Okay, so the angle is formed is known as what? Is known as angle of depreciation. So an angle is formed below the horizontal line drawn with the level of the eye of the observers observer, and line joining, and what? Line joining object with the observer's eye. With the observer's eye. So this is called what? Yeah, so that was called the angle of depression. I hope you understand this point. So the angle of elevation is the opposite of the angle of depression. Okay, my dear friend? Yes. So the basic difference is what is the basic difference? So the basic difference is in the angle of elevation. In the angle of elevation, a person looks upward, and in the angle of depreciation, a person looks downward. So this is the basic difference. Okay. So both the angles both the angles means angle of elevation or angle of depreciation are calculated by the concept of trigonometry. Calculated by the concept of trigonometry. Okay, my dear friends. So this is the condition of angle of depression. Okay. So this is our observer size. This is horizontal line. Here is the object, and this is the line of sight. So in this case, line of sight is below the horizontal line. Line of sight is where? Below the horizontal line. So the angle made by a line of sight and horizontal, this is what? This is the angle of depression. Angle of what? Angle of depression. Okay, my dear friends. So the angle of depression is defined as the constructed by the horizontal line and the line joining the object and observer's eyes. Okay, so what we can write here? We can write it as the angle of depression is defined as an angle constructed by a horizontal line and the line joining the object and observer's eyes, means we can call it line of sight. Okay, my dear friends, I hope you get this point. So this angle is dependent on two factors. That is what? That is height and distance. So this angle is dependent on two factors. That is what? That is height and distances. Okay, my dear friends, so I hope you get this point. Okay, so now let's move on. Yes, Now angle of depression formula. Okay, with angle of elevation, if two of the sides of the right triangle are known, then the formula of the angle of depression is given as. Okay, so what is the formula? So with angle of elevation, if two of the sides of the right triangle are known. Okay, then the formula for the angle of depression is given as, like, okay, like if we know, like suppose we have a right triangle like this. This is A, this is B, and this is C. Okay, my dear friends, so now this is what? This is theta, this is, here is this. So this is a what? Yes, this is our main angle of depression. This is our angle of depression. Okay, so with angle of elevation, if two of the sides of right triangle, this is a right triangle, are known, means if we know any of the two sides, okay, then the formula for the angle of depression is as tan theta. Okay, tan theta is equal to what? Perpendicular upon base. Okay, this is P upon B. So tan theta is equals to P upon B. Okay, my dear friends, so I hope you get this point. Okay, so angle ABO, okay, angle ABC is what? This is angle of elevation, and angle C is this angle is angle of depression. Angle of what? Depression. So these angles, so both of the angles are equal, means angle ABO is equals to ABC is equals to angle C is equals to theta. Okay, I hope you get this point. Okay, so now let's move on. Yes, angle of depression and elevation comparison. Okay, so now we are going to compare these angles. So the angle of elevation is just opposite to the angle of depression. Okay, what is angle of elevation is just opposite is what? Is just opposite to the angle of depression. Okay, so the angle of elevation is formed when it is between the line of sight and the horizontal line. Okay, if the line of sight is above the horizontal line, the angle formed is known as angle of elevation. But in the angle of depression, the line of sight is downward the horizontal, so the angle is formed which is angle of depression. Okay, So I hope you get this point. So this is the basic difference between the angle of depression and the angle of elevation. Okay, my dear friends, I hope you understand these things. So now let's move on. Yes. Now calculating heights and distance. So there are some basic steps which we use to solve the problems or used to find the heights and distances. Okay, so to calculate the heights and distances we can make use of trigonometric ratios. So there are some steps like step 1 is draw a line diagram. First of all we have to draw a line diagram corresponding to the problem. Means whatever the problem is this, first of all we have to draw the diagram. Okay, so draw a line diagram corresponding to the problem. Okay, my dear friends, and step second is mark all unknown heights, distance and angles and denote unknown lengths by variables. Okay, now what is the second step? Mark all known heights, distances and angles. Okay, and denote unknown heights by variable and denotes unknown heights by what? By variables. Okay, my dear friends, and last step number third is use the values of various trigonometric ratios of the angles to obtain the unknown lengths from the known lengths. Means now in this case we have to use the trigonometric ratios to obtain the unknown values with the help of known values. Okay, so use the values of various trigonometric ratios of angles to obtain the unknown lengths from the known lengths. Okay, my dear friends, so I hope you get this point. So let's move on. Yes, measuring the distances of celestial bodies with the help of trigonometry. Okay, so large distances can be measured by the parallax method. What method? Yes, parallax method. So large distances means the distance of planets, stars. Okay, so large distances can be measured can be measured by the parallax. By the what? By the parallax method. Now what is parallax method? So the parallax method is the displacement or change in the object's apparent position. The displacement or change in the object's apparent position when viewed from two different points of view. When viewed from two different points of views. Okay. So what is the parallax method? So the parallax method is the displacement or change in the object's apparent position when viewed from two different points of view. Okay, so the 2 points of view, so the 2 points of view have their own line of sight, okay. And parallax method is measured and parallax is measured as half of the angle between the two line of sight. So my dear friends, I hope you understand this. What is parallax? So this is the displacement or change of object. Means let's suppose we are viewed an object from the two different position. Okay, so there is a displacement or change in the objects after viewing from the two different points of view. Okay, and the 2 points of view have their own line of sight. Okay, so the parallax is measured as the half of angle between the two line of sight. So we have two line of sight because we are viewing from the two different points. So the half of the angle between two line of sight is measured as parallax. Okay, so when you are traveling in a vehicle, and looking around as you are moving, you will see that objects in a distance appear to move more slowly than the objects closer to you. Okay, so the objects which are closer to you are move fastly as compared to the objects which are far from you. This is the effect of parallax. This is the what? Yeah, this is the effect of parallax. Okay, so nearby objects are larger parallax than distant objects. What is? Yes, so the objects which are nearer are larger parallax than distant objects, than far objects. So the parallax can be used to determine distances. Okay, because the nearby objects are moving fastly, so we cannot determine the line of sight of their objects. And while the distant objects are moved slowly as compared to nearby objects, so we can easily find the line of sight and we can easily find the parallax angle. We can easily find the what? Parallax angle. So my dear friends, I hope you understand this concept of parallax. Okay, so the phenomena of parallax when combined with the triangulation will yield the location of the object with considerably accuracy. Okay, so the most of the astronomers regularly uses the parallax method to measure the distances of closer stars. So my dear friends, I hope you understand this concept. What is parallax method? Okay, yes. So when you are traveling in a vehicle and looking around, as you are moving, you will see that objects in the distance appear. You will see that objects in the distance appear to move more slowly than the objects closer to you. Okay, closer to you. So this is the effect of parallel. So this is the effect of parallax. Okay, my dear friends. So nearby objects have larger parallax. So nearby objects. So what? So nearby objects have a larger parallax than the distant object. Okay, so the parallax can be used to determining the distance. Okay, so it is easy to study on the distant object as compared to the nearby objects. Okay, my dear friends, I hope you get this point. Okay, so the phenomena of parallax. So the phenomenon of parallax when combined with triangulation means when combined with the trigonometry, when combined with triangulation means the combination of triangulation and parallax will yield the location of the object. The location of the object with considerably accuracy. With considerable accuracy. Okay, so most of the astronomers regularly use the parallax method. Use the parallax method to measure the distances of what? Distances of closer stars. Okay, my dear friends, so I hope you understand the concept of parallax. Okay, so now let's do some examples. Okay, yes, the question is, a kite is flying at a height of 60 meter above the ground. Okay, kite is flying at a height of 60 meter above the ground. The string attached to the kite is temporarily tied to a point on the ground. Okay, so the string of kite is what? Attached to the ground, attached to the point on the ground. The inclination of the string with the ground is 60 degrees. So now we have an angle. This is what? This is the angle of elevation. This is the what? Angle of elevation. Find the length of the string, assuming that there is no slack in the string. Okay, means there is no curve in the string. Okay, so now first of all we have to draw the diagram. Okay, so the first step to solving like these problems, we have to draw the diagram. Okay, so let's suppose there is a kite. Okay, let's assume that. Okay, this is our kite. Okay, and here is our ground. So this string is attached to the ground. Okay, so now this is A, this is B, and this is C. This is 90 degree. Okay, my dear friends, this is what? This is our string. So we know that the height of the kite from the ground is what? 60 meter. Okay, and the angle of elevation is 60 degree. So now we have to find AC. We have to find what? AC. Okay, so for finding the value of AC, first of all we have to write the given condition. So we have AB is equals to 60 meter. Okay, and angle of elevation is what? 60 degree. And we have to find what? We have to find AC, means length of string. Okay, so now we know that is sine, the value of sine theta is what? Perpendicular upon hypotenuse. Okay, so we have theta is 60 degree is equals to perpendicular is AB. Perpendicular is what? AB, and hypotenuse is AC. Okay, my dear friends, so we know that the value of sine 60 is root 3 upon 2, which is equals to, and we have AB is 60, and but we don't know AC. So by rearranging this, so we get AC is equals to 60 into 2 upon root 3. 60 into 2 upon root 3. Okay, my dear friends, I hope you get this point. So now multiply root 3 upon root 3. So we get 120 into root 3 divided by 3. So it will become 40 root 3, means AC is equals to 40 root 3 meter. So this is our what? This is our final answer. This is our answer. Okay. So now let's move on to the next question. So the next question is, a TV tower stands vertically on the bank of a canal. Vertically on a bank of canal. From a point on the other bank directly opposite the tower, the angle of elevation of the top of the tower is 60 degree. What? 60 degree. From another point 20 meter away from this point, on the line joining this point to the foot of the tower. Okay, so the angle of elevation of the top of the tower is 30 degree as shown in the figure. So we have a figure. So find the height of the tower and width of the canal. Okay, like this. So we have a tower. Okay, we have a tower like this. Okay, so now in this case, first of all we have to find this height, means AB. Okay, and we have to find this length, which is what? This is CB, means width of the canal. From the point C, the angle of elevation is 60 degree, and from the point D, the angle of elevation is 30 degree. Okay, so in this we have DC is equals to 20 meter. Okay, now in triangle A, B, D, means A, B and D. Okay, tan 30 is equals to, what is perpendicular upon hypotenuse? Means AB upon DB. AB upon what? DB. And we know that tan 30 is 1 upon root 3, which is equals to AB upon DB is what? 20 plus BC. This is our tan 30, means 1 upon root 3. So after solving this, we get what? We get AB is equals to 20 plus BC upon root 3, which is our equation number 1. Okay, now in triangle ABC, now in this case tan, in this case tan 60 is equals to AB upon BC. AB upon BC, and we know the value of tan 60 is root 3, which is equals to AB upon BC. Okay, so the value of AB is equals to root 3 BC. This is equation 2nd. Now if we compare the equation 1 and 2, now compare equation 1st and 2nd, we get means 20 plus BC upon root 3 is equals to root 3 BC. 20 plus BC upon root 3 is equal to root 3 into BC. Okay, so if we solve it, we get 20 plus BC is equals to thrice of BC. Okay, so 20 plus 20, if we now we have to shift BC to the RHS, so we get what? twice of BC. So we get the value of BC is equals to 20. Yes, BC is equals to 20 divided by 2. So we get 10. We get what? 10 meter. So we can say width of canal is equals to 10 meter. So this is our first answer. Now we have to find the height of the tower. How we can find it? Now put the value of BC. Put the value of BC in any of the equation. So we are putting the value of BC in equation number 2. Put the value of BC in equation 2. Okay, so we get AB is equals to root 3 BC, means root 3 into 10. So AB is equals to 10 root 3 meter. So this is what? This is height of tower. This is what? This is height of tower. Okay, my dear friends. So I hope you understand this question. So how to deal with this? How to deal with this question? So like this. Okay, my dear friend. So this is enough for today, and I hope you are enjoying our lecture. Okay, so now we will meet in the next lecture with the amazing topics. Okay, so thank you very much guys for listening me, and take care and goodbye.